Hello, geometry students. So this video will just continue on with trigonometry. Today we talk about the sine and the cosine ratio. So yesterday you had the big introduction. The video was lengthy, but sometimes it just takes a while to try to lay some groundwork. So today, hopefully we can be a little bit faster. All right, so let's kind of review what we did yesterday with this opener. So I'm going to go ahead and label this triangle. A is 18, B is 80, and C is 81. And we are going to find the tangent of B. Okay, so all that tells us to do is to write a certain set of sides as a ratio or in a fraction. So the tangent represents the opposite side over the adjacent side. All right, and that means opposite from angle B. So when I look at angle B over here, this side is opposite, and this side is adjacent. And I know this side is adjacent because it's the side that touches angle B. And this is, where students get confused mostly in the beginning because there are two sides that touch angle B. So in trigonometry, the hypotenuse, right, always across from the right angle, will always be referred to as the hypotenuse. And we're going to be using that today with the sine and the cosine. But the tangent will never use the hypotenuse. So the side that's referred to as the adjacent side is the leg that touches the angle. All right, so we're going to go ahead and write 80 over 18, and it didn't say to reduce it, but I'm going to go ahead and reduce it because I think you do have to do that for some of your problems. So that's it, right? The tangent of B is 40 over 9, but now we're going to take it to its 4 decimal place value. So dividing that on a calculator is 4.444 repeating. So we're going to take it 1, 2, 3, 4 places. 4 places out. All right, so that is the decimal version of it. Okay, and that's important because of this chart right here. Right, so this chart is just full of 4 decimal place numbers. And all these numbers are different sets of sides written as fractions. And these numbers are what tie the side lengths to angle sizes within the triangle. So this chart alone would allow me to figure out how big angle B is. So I am going to try to find that 4.44444 number, which is way over here, 4.3 and 4.7. So, it's in between these two. You have to make a judgment call. You could kind of figure it out in your calculator which one's actually closer. I'm thinking the 77 degrees looks a little bit closer. Alrighty, so that would tell me that this angle right here would be 77 degrees. All right, and I'm not totally sure these triangles are drawn to scale, so don't go judge by how it looks. This same triangle is going to be used for 3 different problems. All right, onward. And finding the sizes of the angles is not something we have to be able to do just yet. We really just need to know how to do a tangent. Okay, now we'll move on to the tangent of A. Okay, so that means, I don't think I went over this on the B, but that means from A, right, we're going to go opposite. So that's 18, and adjacent will be 80. Okay, so you got to put your pencil here and then do the opposite and adjacent sides. Okay, so 18 over 80, 9 over 40. When you divide those, you get 0.225 and then nothing else. So if you wanted to take it to that last decimal place, you would add a 0 on there. Okay, and then we would look this angle up if we wanted to figure out how big that, or look this side ratio up to figure out how big that angle is. Okay, now we'll go ahead. I'm going to erase my markings on my triangle because number 2 is actually a new problem, uses the same triangle. Okay, so side A is 17. Angle A is 31 degrees. Side B is what we're trying to find. So we have to kind of ignore the hypotenuse and just realize that from this angle, this side, and this side, these three components together, I can put together a tangent equation. So now, instead of writing the tangent of A equals 17, A over B, I'm going to go ahead and replace that A with 31 degrees because I know how big that angle is now. 17 over B. Okay, so from here, we're just going to go ahead and solve for B, but this number right here, we can get from our chart, right? This tangent of 31 degrees, let's go find 31 degrees. 31 degrees, we go over to 0.60009. That is just the ratio of the opposite, right? If you knew the opposite side and the adjacent side, and you wrote them as a fraction and then took it to 4 decimal places, it would be that number right there. So we're just going to replace that side with that ratio, 0.6009. And we know that that has to equal whatever 17 divided by the B side is. Okay, and it's an approximation. That's the reality. Trig is, everything in trig is approximating because we're always rounding our decimals. Okay, so to solve this equation, I mean, this is kind of tricky because the B is in the denominator and I don't want it in the denominator. So mathematically, what I'm going to do is times by B over 1, because those will cancel. And then when I times the other side by B, I eliminate the, then the B ends up in the numerator. So I get B times 0.6009 equals 17. Okay, and then it's a kind of weird number, but you're just going to divide both sides by 0.6009. Right? Okay. So we are going to do 17. Let's see, I'll bring my calculator in here. 17 divided by 0.6009. And we get 28 point, and then there is always some confusion. Do we take this one out 4 decimal places? And the answer is no, because all we're doing is finding a side. That only has to go 1 decimal place, and sometimes, we would just maybe write it as 28, but I'll go ahead and do 28.3 because it didn't really specify where to round it. Oh, it does, sorry, nearest 10th. That's 1 decimal place, so just to 0.3. It's only when you're doing this side ratio computation that you go 4 decimal places. That one should never be rounded down to just 1 decimal place. Okay, and last warm-up. If A is 9, B is 11, find little b to the nearest 10th. All right, so between the 11 degrees, the 9, and the b, these 3 together can be written as a tangent equation. All right, because this is the opposite side to angle B, and this is the adjacent side to angle B. So when you have an angle with an opposite side and an adjacent side, that is a tangent equation. So we're going to say the tangent of, instead of B, I'm going to go ahead and replace that B with 11 degrees, right? And that's equal to opposite side, little b, over 9. Okay? Now, instead of using the chart, you could go ahead and do the tangent of 11 degrees in your calculator. 0.19438, right? All right, so we're going to, because this is the side ratio. I'll put it right here. So this one does have to go to 4 decimal places. We don't want to round this one just to 1. We're not finding the length of the side. We're finding the tangent of, 11 degrees. So 0.194 would go for 4, right? That 3 would round up to 4 because that's an 8. All right, and we just kind of did a rounding. So that's equal to b over 9. Okay, solving. We're going to times both sides by 9 over 1 to cancel the 9. 9. And I feel weird going across the paper, but that's just how the paper has ended. Okay, 0.1944. Actually, I'm going to go back one step. When you use your calculator, you can be more accurate than the chart, because even though we rounded it here, I'll just keep the whole number in my calculator. It's a little bit more accurate, and that's the number that I'm going to times by 9. And sometimes it does give you slightly different rounded answer in the end, but that is okay. So this is going to be 1.7. All right, so now we're going to just go ahead and write all the trig ratios. So here's our right triangle. Put the right angle on there. And again, you can name your right triangle the angles any way in order that you want. I'm going to go ahead and go A, B, C. All right, but once you have your big A, big B, big C labeled, you got to make sure across from big A is little a, little b, and then little c. All right, so we already know what the tangent is. Let's go ahead and just write that down. So that's just a ratio of the opposite side over the adjacent side. All right, and then you have to know where to look, right? You should be looking at the A. So when I look at this A right here, opposite to A is little a. Adjacent to A is little b. All right. So now we are going to do the sine ratio. So the sine is a ratio of the opposite side to A over the hypotenuse. Okay. So again, that is if you're looking at A, that's where you look. So in our case, opposite to A is little a, and hypotenuse is just hypotenuse, right? I always identify that as the side across from the right angle. So in trig, the hypotenuse is always going to be referred to as the hypotenuse. These two sides are going to change relative to what angle you're looking at. Sometimes A will be opposite, sometimes it will be the adjacent side, if you're looking from angle B. So that's A over C. All right, and then the cosine is going to, from angle A, is going to be, well, adjacent side over hypotenuse. So again, we're going to look from angle A. The adjacent side is B, and the hypotenuse is C. And that's it. I don't know. Sometimes people get disappointed that that's all that the trig is, but I will say this is the tip of the iceberg with trig. There's a lot more to trig than simply doing side ratios. So this is kind of where it all begins. All right, so here's a little mnemonic for remembering, because people often forget which way to stack the sides, so they can't remember if the sine is adjacent over hypotenuse or opposite over hypotenuse. So this little mnemonic is called SOHCAHTOA. Anyone who's been through a basic trig function will know exactly what SOHCAHTOA means. So the S right here represents the sine, okay? And then the O and the H represent opposite side over hypotenuse. So they're just reading this little equation off in this little mnemonic. So sine is opposite over hypotenuse. All right, so cosine is adjacent over hypotenuse. Cosine adjacent over hypotenuse. So the C is for cosine. This is adjacent over hypotenuse. And tangent is opposite over adjacent. So SOHCAHTOA. It sounds weird. You'll get really familiar with it in this unit. And I have seen it written like this before, which some students prefer. So SOHCAHTOA. So that just helps you remember it's opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, so basically we're just going to be doing a lot of practicing with our SOHCAHTOA. All right, so here they've given us a right triangle and we are asked to find the sine of u, sine of w, cosine of u, cosine of w. Write each answer as a reduced fraction and as a decimal rounded to 4 decimal places. Okay, so sine of u, remember this tells you where to look. Okay, and so we're going to put our pencil on u, and we're going to remember our SOHCAHTOA. I'll write it at the top here. SOHCAHTOA. Okay, so we know that the sine is the opposite over the hypotenuse. So from angle u, opposite is 16, hypotenuse is 34. All right, reducing that to 8 over 17. And then just literally in your calculator, hitting 8 divided by 17, 8 divided by 17, and we're going to just take this to 4 decimal places, right? 0.470, this would go to 6, since that's an 8. So 0.4706. And again, these decimal numbers are the ones that you're generating from this chart right here. And they do have to go 4 decimal places. All right, so anytime you're doing the actual ratio, side over side, is when it goes 4 decimal places. All right, sine of w. So sine of w, I'm going to put my pencil on w and go opposite over hypotenuse. So this one is going to be 30 over 34. So that's 15 over 17. You can see this is an 8, 15, 17 triangle family. And that's 0.8824. Okay, now we move on to the cosine of u. That means we look at u. And we know a cosine is adjacent over hypotenuse. So from u, the adjacent side, the side that touches the u, is 30. And the hypotenuse is 34. So this is something, I mean, really, this is something that you get into a lot more in Algebra 2, but it's kind of cool to see that the sine of w and the cosine of u are actually the same ratio. There's some fun, cool stuff you can do with that. We don't really get into that in this unit, though. All right, cosine of w. So from angle W, we're going to do adjacent side, 16, over hypotenuse, 34. All right, so that's 8 over 17. Cosine W, same as sine U. 0.4706. And even though we're not there yet, I know I've shown it and said it a bunch because it's important that you have the big picture, but we could look up those numbers here and then figure out how big the angles are from that information. All right, so just, you know, I'll do the first one here, but making sure you can use your calculator. So the sine of 25 degrees from our sheet means that we are going to go down to 25 degrees, and the sine column is the very first column. So here's where you got to be careful that you get into the right column. 0.4226. All right, and then the calculator, I mean, it's not that big of a jump. We did the tangent yesterday, so let's do sine of 25 today. Sine 25. And I got 0.4226. And again, if you're not getting these numbers, make sure your calculator is in degree mode. If it's not, you'll be getting different numbers. Okay, so go ahead and do the rest of those. I'll pause the video. Okay, so there they are. Kind of kind of redundant, maybe too many questions there, but all right, so now let's go ahead and move on to solving. All right, so the big picture with this is we can now solve for missing sides on right triangles, right? Where before we were stuck with this. We didn't have enough for Pythagorean theorem, and since that wasn't in our 30, 60, 90 family, we don't really have enough to use a family. So now we're going to use the trig to help us get that. All right, so here's what we have to do. We have an angle, and relative to this angle, this side is opposite the angle, and this side is the hypotenuse. So I'm going to just look at my SOHCAHTOA and see. I'm going to write it down here. SOHCAHTOA, right? Which of the trig equations, relationships have I got if I have got an angle with the side opposite and the hypotenuse? So the only trig function that puts the opposite side and the hypotenuse together is the sine, right? So I am going to write a sine equation. You guys, you have to write sine. You can't just punch it out in your calculator and give me some number, okay? Sine is part of is the first step on this. Now that's glary. So the sine of 56 degrees equals opposite side over hypotenuse. Right? And from there, we're just going to solve it. Okay, I turned my light back on. It seemed too dark and shadowy before. So I'm going to look up sine of 56 degrees on my calculator, or my sheet here. So there's 56 degrees. Sine is the first column. Okay, so I'm going to use this number 0.8290 and take the whole 4 decimal number. Okay, so just a reminder, this number, right? This is, all these numbers get generated by just us doing those ratios of sides, right? This is the opposite side of some triangle over the hypotenuse. You divide those out, and that's the number that you're getting back. So that's why we're putting it here, right? We're setting that equal to, hey, that we know that when we take the opposite side over 20 and divide it out, it has to equal that number. Okay, solve for x. So times 20 over 1, not over x. Okay, and then we'll go ahead and do 20 times 0.8290. And we get 16.58. All right, so again, this is not finding a side, right? X should not go to 4 decimal places, or really even 2 decimal places. In fact, I guess the directions say to the nearest tenth. That's 1 decimal place, so 16.6. But you need to know, when to take it 4 versus when to only take it 1 decimal place. That's kind of part of learning this unit. All right, let's do the next one. So what is x? So we're going to look, we have this angle. This side is considered the adjacent side because it touches the angle. And even though this side also touches the angle because it's across from the right angle, it's considered the hypotenuse. So when you use your SOHCAHTOA, the trig ratio that relates this angle with an adjacent side and a hypotenuse is the cosine, right? So we're going to write a cosine equation. So cosine of 42 degrees equals adjacent over hypotenuse. Okay, so I'm going to kind of show for this one, instead of replacing that number, you can just keep cosine 42. We know we can look that number up or use it out of our calculator. Times both sides by 11, times both sides by 11. So if you want to just put that straight into your calculator, that is okay, right? That's kind of a little bit of a shortcut that's acceptable. So I'm going to say 11 times the cosine of 42, right? And I get 8.1745. All right, so again, because I'm finding a side length, I'm not going to take it 4 places. I'm only going to take it 1 place. So that would round to 8.2. Alrighty, so we have an angle. This is an adjacent side, and this is a hypotenuse. So when we do our SOHCAHTOA, adjacent and hypotenuse are a cosine. So So we're going to write a cosine equation. And yes, you have to write the word COS as part of your starting equation. You can't just jump into a number. I need to see that you have the right value there. So cosine of 21 degrees equals adjacent, which is 11 over x. Alrighty, I'm going to go ahead and replace this number. Okay, I'm just going to use my chart. I just want you guys be comfortable either way, right? So here's 21 degrees. Cosine is the middle column. So we're going to go down to the cosine of 21 degrees, which looks like 0.9336. All right, and we know that that's the side ratio, adjacent over hypotenuse. So that's going to help us. We know that when I take 11 divided by x, that has to equal that. Okay, so this is one of the ones where the x ends up in the denominator. So I'm going to get it out of the denominator by timesing x, both sides by x, not x over 11, just x over 1. Okay, so then I get x times 0.9336 equals 11. Divide by 0.9336 to solve for x. All right, so x divided by 0.9336. Sorry, 11 divided by 0.9336. Let's go ahead and do it. 11 divided by 0.9336 is 11.8. Another example. So we have an angle. This side is opposite, and this side is a hypotenuse. Okay, so an angle with an opposite side and a hypotenuse is a sine. Right? If I use my SOHCAHTOA, the sine is the one that does the opposite and the hypotenuse together. So we're going to say sine of 50 degrees equals 19 over x, right? Opposite over hypotenuse. Alrighty. Now, on this one, I'm not going to replace the sine 50 with a number. I'm just going to keep it as sine 50. All right, so I have to multiply both sides by x. So I get x times the sine of 50, whatever that decimal number is, equals 19. All right, now I'm just going to divide that number away. Sine of 50. Sine of 50. Okay. And this now is calculator ready. Just put that in your calculator. Right, 19 divided by sine 50 equals 24.8. Okay, so the last one looks like a word problem. It just is a glorified SOHCAHTOA problem, right? It's a rectangular basketball court. We are going to walk from corner to corner, essentially cutting this rectangle into a right triangle. So this seems strange that you would know this information about a basketball court and not the and not like the one of the dimensions, but we know this is a 62-degree angle. So we are going to write and solve a proportion using a trigonometric ratio, approximate the distance of our walk. So this side right here is opposite that 62-degree angle. This is a hypotenuse. All right, so opposite and hypotenuse is a sine. So we are going to do the sine of 62 degrees equals 94 over x. All right, and I always think it's just a little bit cleaner to not replace this sine 62 with that 4 decimal number, so I'm going to go ahead and keep it like this. Multiply both sides by the x. X sine 62 equals 94. and then divide that number away. Sine 62, sine 62, 94. I'll just go ahead and do it, right? 94 divided by sine 62 in the calculator. Okay, so we're going to do 94 divided by sine 62 and get 106.5. All right, and it looks like units are feet and feet, so this would be feet. All right, thank you for watching.